Taking a look at Friday afternoon and into the evening, it looks like there is a pretty good chance of having some significant severe weather along the Ohio River. The SPC has it lined out as a 30% chance of significant severe weather to occur in this region as well. I'm going to dig into why that is. So, the 500 millibar, it has pretty good agreement across all the models of this closed low in this general area. Some of them are a bit faster, some of them are a bit slower than the wrap, but in general, it's okay. Very good agreement across the board. What has me concerned is how the jet picks up along the Ohio River, and so that's really going to be one of the driving factors for having some severe weather in play. The low level jet, it has a southwesterly flow to it. If it was a bit more southerly, then that would be really good for having some severe weather in play. But this southwesterly is okay. If it was a bit further westerly, then I would say that there's too much dry air that could be potentially entrained into this system, and so that would help choke out the severe capabilities. But that's not happening. We have a southwesterly wind pattern, and since we're a bit farther south than what's going to be happening on Thursday, there's going to be a bit more moisture being pumped in since we have a predominantly southwest all across from the Gulf up into the northeast. And that is exactly what's happening based on the relative humidity charts. We have an uptick in the humidity around that same region. It's a bit drier right here. Not exactly sure why. It could just be models being models. So, um, something to keep an eye on with this as we continue on with this forecast. So across this general area, we have some pretty high cape across the board, ranging from 1,500 all the way to nearly 4,000. So that's pretty good indicators of having the really buoyant atmosphere we need to have those air parcels generate that lift. What is a bit concerning, though, is looking at the convective inhibition. There is quite a bit in this area, so maybe a bit further east we could have some more tornado development. But in general, it's pretty spotty, so it's a good indicator that the current model is over forecasting it, possibly. So, looking at the wrap and the lapse rates associated with this model run, I'm not really a big fan of how it's under forecasting compared to all the other models. So I'm going to go ahead and show you the NAM for this. As you can see, it is much more significant in strength, 8.4, 8.5 Celsius uh, degrees Celsius per kilometer. It's much stronger than 6, 5.8, what's being shown in the wrap. So I'm going to continue on looking at the NAM for now. So both the NAM and the wrap are in pretty good agreement of having some really strong bulk shear in the area. Um, as you can see, it is ranging from 50 to 70 knots, and the same can be said in a more centralized area near the Illinois and Kentucky border, 75 knots, and it drops down quite a bit right here. So in general, I would say that the NAM is probably going to be more accurate with this, especially since the 3 kilometers showing something similar to that as well. There's quite a bit of disagreement between the models with the storm relative helicity. The RAP has it very high values in southern Illinois, up to 450, and the NAM has it a bit farther west and even stronger at 638. So that is a big difference and something that makes me lose confidence in how these storms could play out. GFS has it a bit further to the east, so I would say that in general, somewhere around this area, again, where that probability is forecasted, is where we could have the most significant severe weather to occur. And now, with all those things in mind, going to take a look at the supercell composite, where a lot, or the GFS, the NAM, and the RAP are all focusing in on near Louisville, Kentucky, having the highest supercell composite. Um, Still, I don't think it necessarily lines up with what I've been seeing, especially with the storm relative helicity, but it's still something that helps create a forecast and have higher confidence in the severe weather threat in north central Kentucky. And now looking at the surface based cape with photographs overlaid, uh, very high surface based cape. Keep in mind that the mixed layer cape is not going to be this high, and mixed layer is what I'm using to forecast. So this is going to be a bit higher than what is expected as of right now. But in general, the photographs are fairly straight, and so that would be another good indicator for having more of a hail threat as opposed to a tornado threat. And that is pretty prevalent when we click on a sounding. We can look at the SHIP, which is 4.9. SHIP is significant hail parameter, and 4.9 is very high. If you've watched my previous videos, you know that I mentioned that the SHIP has to be between 1.5 and 2 to indicate favorable environments for significant hail. So 4.9 is extremely high and a very good indicator for having large to very large hail. And now to show the significant tornado parameter, just to debunk anything that's going to be shown as I post this video. So there's a lot of disagreement on where the highest tornado parameters are. So this is the NAM, and then here's the RAP, and here are some experimental models from NOAA, which aren't supposed to be used for decision making, but it does help prove my point that there's a lot of disagreement between all the models of a high SIGTOR parameter. Now to take a look at a NAM point-based sounding just to the southeast of Louisville, Kentucky. There is a very stout, very strong elevated mixing layer, and that's really going to help with any sort of tornado development that can happen, as well as just generate that spin that's needed to help favor supercells. Another thing too is how the winds steadily increase with height. In previous forecasts, like for example, the moderate risk in Minnesota that we had a couple weeks ago, that wasn't the case. The winds were pretty erratic, and they were highest around the 500 millibar mark, and then started to decrease quite a bit above that. But in this case, the winds are steadily increasing. What I don't like, though, in terms of severe weather development, is how the surface winds are southwesterly. If they were more southerly or south southeasterly, that would really help generate that low level shear needed to generate supercells. However, regardless of that wind pattern, the overall pattern in general, synoptically, looks like it is favorable for all hazards, especially large hail. This is 5.4 significant hail parameter, which is even larger than what I was showing in southern Illinois earlier. So the hail threat with this is very real, and it can damage quite a bit. So now to wrap up the forecast, going to look into the SPC summary for this event. Um, Pretty much everything that I mentioned is right in here. The risk for all hazards is accompanied with this activity, including very large hail, tornadoes, and intense wind gusts. I cannot stress enough the very large hail based on what we have right now. If the trends continue, once we get more convective allowing models for this setup, if they continue to show a high ship, then we could have a very damaging hail event happen on Friday.